All right, so here we go. Tuesday morning. One of the last things that you guys basically will have new material-wise in terms of your test next Tuesday is looking at some stuff with probability. We've already used it once. We used it with our dihybrid crosses. And we talked about probability is the way of basically predicting the number of times a random event is going to occur. So we've already used the multiplication rule or the product rule. It's sometimes also referred to as the end rule. So the notes that you guys have here and the ones that I've attached, my advice, either download them, save them, print them, or go through and write down the basics. Hey, two laws, multiplication and rule, addition or rule, and go through some examples so that you guys can utilize them to go through the activity that you will see next. Okay, I didn't want to go through and rewrite everything because I think everything here is kind of important, especially the examples, but I don't know if you guys really need to write the examples down if you have them online for you someplace. So we're going to start off with the multiplication rule, which is also known as the product rule, and like I said, it's also known as the end rule, and that's what we utilize with dihybrid crosses. So with dihybrid crosses, we looked at two different traits. So we said plants, first off, they could be tall or they could be short. That was the first allele we talked about for height. Well, they also had a second allele that we looked at, either green or yellow, or a second trait with alleles that we looked at, either green or yellow. But we wanted to know how many of those plants could be tall and green at the same time. How many could be tall and yellow at the same time? How many could be short and green and short and yellow? And that's where we use that multiplication or product rule. So that's where I kind of went through and did the Punnett squares with two different boxes, and I went through and added them all up and multiplied them through for you guys. That's the way that we're doing here. So if we think about it, let's think about a deck of cards. If you guys have a deck of cards at home, pull it out, look at it. You can look at your hearts. You guys can look at all your different suits that you have on there. So if you guys look at that deck of cards, what you guys should realize is that there are 4 different suits. So meaning the 4 different shapes, the spades and the diamonds and the clubs and the hearts that you have on there. And then there are 13 different, let's say, characters. I don't want to say numbers because they go 2 to 10, and then you got your jacks and your kings and your queens. So you have 13 different characters on those particular cards. So we want to know the probability of drawing a heart from that well shuffled deck. Well, we know that there's 4 different faces. We have hearts and spades and diamonds and so on. So we have 4 different ones that are there. So the probability of drawing a heart is going to be 1 out of 4. Every 4 cards, you're going to see one of those because we have 4 different suits within that particular deck. The probability of drawing a 10, just the number 10, I don't care what else is on it, just the number 10, is 1 out of 13 because I said I have 13 different characters, 2 to 10, jacks, kings, and queens. So if I think about the probability of drawing a 10 and a heart, so that card needs to have both of them on there. It has to be a 10 and a heart. That's where we're going to use that multiplication rule. So we just said, looking for that heart, it's going to be 1 out of 4. Since it is an end problem, we want to go through and multiply it. 1 out of 4 times 1 out of 13, which is my 10. I have a 1 out of 13 chance. I'm going to multiply them through. I have a 1 out of 52 shot of pulling a 10 of hearts. I only know there's 1 10 of hearts in that particular deck of 52 cards. The second one, we're going to look at the probability of 2 or more independent events occurring simultaneously or at the same time is the product of their individual possibilities. And this is what you guys are going to kind of be doing for your activity here in a moment. You guys are going to be flipping coins. So if you have a couple coins at home, great, pennies, quarters, whatever, my advice, keep the same coins. Don't make it a penny and a quarter because that's not scientific method. You're not keeping all your variables the same. They should be the same kind of coin, same size, same weight, that sort of thing. What we're looking at here, if you think about the multiplication rule still, the probability of 2 or more events occurring at the same time is the product of their individual probabilities. So for example, if I flip 2 coins at the same time, the odds of getting heads on both those coins, if you're looking at it, the odds of getting heads on both of those coins is also going to be heads on the first one and heads on the second one. Well, that first coin, I have a 1 out of 2 shot. I have a 50% shot. It's either going to be heads or it's going to be tails. So I have a 50% chance, a 1 out of 2 chance. That second coin is also a 50-50 shot. Probability that I get heads on the first one and the second one. So I'm going to do 1/2 times 1/2 is going to give me that 1/4 that you guys see there. Okay, so I have 1 half times 1 half, I have a 1 out of 4 shot of getting heads on both of them. What else could I got? I could have gotten tails on both. I could have gotten heads on one and tails on one. I could have gotten tails on one and heads on the other. And you guys will kind of see that on your activity. So there's 4 possible kind of combinations that we can create there. The other one that we're looking at, the other rule that you guys will be seeing is your addition or rule. So you want to know the probability of one or the other of the 2 mutually exclusive events happening. You're going to add the individual probabilities together. So you have to kind of see how they're worded and what you guys are physically looking for in that particular problem. So let's think about it this way. Note that the 2 traits of interest, let's say gender or birth of month, are not mutually exclusive, meaning you could be a female and you could be born in January. They're not relatable events there, but there are possible phenotypes within each trait. So you can be born in January, you can be born in February, you can be born in March, April, so on. Those are mutually exclusive events. Let's think about our well-shuffled deck again. The probability of drawing a heart from that well-shuffled deck, we already know it's 1 out of 4. Clubs, spades, hearts, and so on. I have a 1 out of 4 shot of grabbing that heart. The probability of drawing a spade is also a 1 out of 4 shot. Spades and hearts are mutually exclusive. I will never have a spade and a heart on the same card. They're all going to be on different cards there. So since they are mutually exclusive phenotypes, it is impossible to have both hearts and a spade. The probability of drawing a heart or a spade is 1/4 plus 1/4 gives me 1/2. That means half the cards in the deck are either going to have a heart or a spade. We are going to add them together anytime you see that word or. I can't draw a heart and a spade if I'm pulling one card. I'm never going to have both those suits on the same card, so I'm going to have to add them together. If we're thinking about dice, so if you take some dice and you're rolling them, the probability of either one or the other of 2 mutually exclusive events occurring is the sum of their individual probabilities, and that's what we're looking at here in problem number 2. So for example, if you roll a standard die, the odds of rolling either a 1, you have a 1 out of 6 probability because you can roll a 1, a 2, a 3, a 4, a 5, or a 6 if I'm just rolling one single die. Or I roll a 2. So if I'm rolling that one single die, I'm looking to either get a 1 or a 2. If I'm rolling a 1, I have a 1 out of 6 probability. If I'm rolling a 2, it's a 1 out of 6 probability. What's the odds of rolling a 1 or a 2 on that single die? I need to add them together. 1 6 plus 1 6. I have 1/3 of a chance of rolling a 1 or a 2 on that particular die. Some other words that you guys have either kind of seen along the way, or we'll see a little bit more when we get to genetic mutations, gene linkage. So some of these we'll see a little bit more when we get to mutations, because we'll see it more with the terms of mutations. So genes that are usually inherited together because they're found close together on the same chromosome. If you get one gene, it's likely that you're going to get the linked gene. So a good example of this is white dogs. White dogs are usually going to be deaf in with their hearing. So those genes are pretty much linked. If you're getting that gene for that white color, you're usually going to get that gene for being deaf as well. So these are genes that are linked together. So when we did dihybrids, we said, oh, you know what? Mendel said that a lot of these genes are not linked. It's not like, oh, if you're tall, you're automatically going to be green. Or if you're short, you're automatically going to be yellow. We have kind of independent assortment going on. Well, there are some genes that can be linked together. Karyotype, we kind of talked about it before when we were in school. It's a picture of all your chromosomes. And we'll go back and look at those 46 chromosomes, which we said are in 23 pairs. The first 22 pairs are autosomes. The last pair are your sex chromosomes. But you guys will be seeing a little bit more of that. Last one is polygenetic inheritance or multifactorial traits. So when we've been doing a lot of these problems, we're like, oh, eye color, brown eyes is dominant to blue eyes. It's not always that easy. So when we look at things like that, sometimes with eye color and hair color and skin color, it is controlled by many, many different genes. So you might have a gene on chromosome 1, you might have a gene on chromosome 7, you might have a gene on chromosome 8, and all these genes work together to give you eye color and hair color and skin color. And this is why we have so many variations of these particular things. It's not always just going to be one gene that controls that. Okay, so like I said, go through, maybe write down rule number 1, rule number 2, your multiplication rule, your addition rule, and write down some little examples that go along with that. I'll be back in a moment. I'm going to go through the activity that you guys are going to be doing today. So if you have a couple coins, 2 pennies, 2 quarters, 2 nickels, whatever you guys may have, go get them, and I'll go through some of the steps that are on that with you guys in a moment. So I'll be right back.